Hola a todos y todas. My name is Maria Teresa Grifa, and I'm really pleased to be with you today. In this presentation, I want to drive you in the object-oriented programming in Python, and I hope you will enjoy this presentation as much as I did brainstorming it. I introduce myself. I'm currently a PhD candidate in applied mathematics at the University of L'Aquila in Italy. And from January, I'm starting a new job as a machine learning specialist for an Italian company. But let me introduce you the main character of my story. Lewis Carroll is the alter ego of Charles Dodson, and Dodson was a conservative English mathematician during the Victorian age. He was pretty unpopular during this time, and he was distressed by all the new theories in mathematics appearing during his age. But nevertheless, Dodson was more than that. He was a photographer, a priest, and an avid gamer. This all to say that Lewis Carroll was a Victorian nerd, and he would have been a Python user too. Carroll is the author of Alice in Wonderland, and his novel contains parodies and tons of hidden maths puzzles. Alice in Wonderland madness have been enormously influential in the popular culture and art. Carroll was obsessed by the number 42. I believe that most of us set the random seed of a machine learning experiment to 42 for having the reproducible results. 42 compares in each hiker guide to the galaxy as the answer to the greatest question calculated by a supercomputer named Deep Throw. And in Alice in Wonderland, we can find the 42 illustration and the rule 42. So here is how I will use object-oriented programming to explain you one of the hidden 42 games in Alice in Wonderland. So let's introduce a class. The class Wonderland member. So here, the constructor underinit is required to initialize the attribute of the class, the name, the species, and the fantastic. The first argument of the underinit method is called self, and it points towards an instance of the class whenever the method is called. And the wrapper method is used to ensure a useful conversion of the object to a string. So here we define the mad hat as an instance of the class, and using the wrapper method, we can easily recreate the mad hat instance. Then we add the class method decorator for define the main character, the hero of our story. The class method takes as a parameter CLS, and CLS point towards the class and not a particular object instance. A class method can only modify class state, but not object state, as you can see here. So next we add a property using the property decorator, and we use it to define the mood of a character. So the property decorator allows us to create read-only property that can be accessed by the dot syntax. Now we add the getter and setter, and we use it to define the interpretation of a character. So the getter method is used to get the value of the property, while a setter method is sets the value of the property. So we define a local attribute interpretation, and we use the property decorator to modify our attribute in such a way that the users of our class no need to make any change to the code, their code. So we add the setter to the property for set the proper value. So we define caterpillar instance of the class, and with the dot syntax, we can access to the interpretation assigned by property. Then we can change the interpretation of the caterpillar from a wise adult to a hip yucca smoker, and this is done using the setter. But then we can set the value by calling the property method using the class name, Wonderland member. And we set it to teacher because every character in Wonderland teach Alice something new. Now it's the turn of the class instance inheritance. So let's add a child class to class Wonderland member that now became a parent class. So we define strange animal that inherits Wonderland member, and inheritance allow us to create a new class that inherits all the attributes and methods from the parent class. And in its init function, in its method, we use the method super to call the init method of the parent class, and then we can add more attributes. Here we initialize the rabbit object, and we see that contains the property mood that was defined already in the parent class. Now we want to know how many times 42 appear in the book. So first of all, we download the book from the Project Gutenberg, as you can see here. And then, using some NLP toolkit, we plot the frequency of the word 42. As you can see, at the first look, the word 42 appeared just once. But using prior knowledge or Wikipedia, one of the riddle containing 42 appears in chapter 2, The Pool of Tears. So let's define a data class for setting up our players of the game. So data class figures in Python 3.7, but if you are using a Python 3.6, you can install it, use pip install data classes. Here, we create a data class using the data class decorator. A data class structure is basically a mutable name tuple with defaults. And here we define the attribute name for the player. However, data class implements several useful methods by default. In fact, when defining a player class, Python automatically adds the underinit and the report method that looks like this. So now we add some more advanced features to the data class. So we define the count players using class variable and the player number using the function field. So we modify the values of an attribute using the post-init method. So the post-init method is called by the inbuilt underinit after initialization of all the attributes of the data class. And it's used to update the number of the players in this case, as you can see in this example. Now we add also an instance method for checking who will be the first player. This method will raise an error if when Alice is the first player, and print let's play if Alice is the second player. So now let's go through the hidden riddle, which is a multiplication table. So in chapter 2, Alice attempts to do simple multiplication, but this produces some odd results. So we generally work in base 10, so we have 0 through 9 digits with which we perform operations. But Alice tries to compute multiplication in base 10, but in Wonderland, her answer slipped into a higher basis system. So she can get to 20 because of 42. But let's see how. So in this slide, we have the multiplication rolling base representation. So the multiplication of 4 by 13 fails to return a number in base 10 because the base that we are using is 42. And 4 by 13 is equal to 52 in base 10, but it's equal to quote 1xi in base in the representation of the base 42. So now we define the class rolling table multiplication, where we add some static method to define the rolling index of the matrix and a custom base representation, which is as a custom method based on the base representation in Python. Here there is a print of the triangular matrix. And now let's define the game as a child class of the previous class. And here we define an instance method from writing a piece of chapter 2 in a text file, then another instance method to read for this text file, and then the game will appear as the output of the method talk and play. As you can see from here. In conclusion, I encourage you to have a look to the Zotorenis GitHub page that was very inspiring for me. I would like to recommend you a nice book for improve your Python skill, Fluent Python by Luciano Ramallo. And I would like to thank Patricio Reis. You can find his GitHub page here, his LinkedIn page here. And I would like to, if you would like to have a look to other Carroll games, just have a look to my repo that is listed here. So feel free to drop me an email if you want to collaborate for coding project. And thank you for your attention.